Also, yeah, I think we have a question here for you from Dr. Zekular.
Sure.
Hey, Ophelia, that was really great. I made them put me back in here just so I could ask a question because I was so excited.
Yeah.
One thing I just wanted to say, which I think is important, is that so metronidazole isn't used in adults anymore, but it's still used in kids. And so it's very, I think what you're doing is very important and applicable because we see a lot of recurrence in kids. There's a lot of reasons that could be, but it's certainly not obsolete yet. We'll see.
Interesting.
Yeah. The other thing I was going to talk
Actually,
about
I have a question about that.
Sure.
Sorry, is it used in kids because fidaxomicin or vancomycin have like some negative effects, or like why? I guess why is it still used in kids but not in adults? Yeah.
I think that's a fundamental issue with pediatrics, right? Is that it's very behind. The studies with vanc that showed that both vanc and fidaxomicin are better than metronidazole have been done in adults but not in kids. And I think in general pediatric medicine kind of lags behind in some of these spaces. And like is there so in high risk populations like IBD, they will use vanc because presumably metronidazole has been shown not to use, but in general in pediatrics, metronidazole is still used quite a bit.
Interesting.
Yeah, so it's not like there's adverse events in vanc. They use vanc, for other reasons in kids.
Okay.
But I don't know, just like ammunition.
That's very interesting. Yeah, I didn't know that.
So I think about metals a lot with just bugs and C. diff in general. And the hydrogen sulfide story I think is interesting because I would imagine that hydrogen sulfide is actually a really minor player in metal starvation compared to just battle for metals with high affinity import systems and siderophores and things like that. So do you think that there might be two things happening here? There's like a competition for metals and starvation that could be playing an important role, and then also a hydrogen sulfide role that could be separate and also overlapping. Did you look at other, like does what is it, the sulfa D-piger, does it have does it dedicate a lot of its genome to metal uptake? Is there like anything?
That's such a good question. And also, I mean, these questions are so great. I hope I remember them. Yeah, I mean, I don't think we looked at like siderophores in D-piger. We automatically thought of hydrogen sulfide because it's so salient, what in vitro. In vivo, we haven't tested any of this in vivo, so I think that'd be really interesting. But yeah, so that's a great question. I don't know if D-piger is producing siderophores or other types of metal sequestration mechanisms that could also be affecting this process. And it's not just hydrogen sulfide, and also in the gut, maybe that's also really important too to consider, like how that's affecting antibiotic susceptibility.
Yeah, to go back to the name of the session, like context matters. It very well could be the crux of what makes you susceptible, or like the effect of metronidazole being a clearing infection or relapse, or like a non-responder, right? It's very cool.
Yeah, that's so fascinating. Yeah, that's really interesting. We will have to look into that. Yeah, we haven't tested this in vivo. I'm very interested, but it's tricky. So
yeah. Oh yeah. So but fantastic. Thank you.
Yeah, thanks.
Awesome. Well, thank you both so much for your presentations. And yeah, it was an honor to have you both here.